All right, so this is, I notice I put forces without friction, so we're going to go ahead and actually set up this problem. So we have, and I'm going to do this in two different colors for each box. So um, now you know what, I'll leave it in one color. Here's what we'll do though. For this mass here, we have a normal force pointing up, and we have its weight pointing down. Now remember, whenever we see a rope, we draw a tension going out of the rope. For little m, we have a tension going up, and we have its weight going down. And I want to distinguish between these two forces. So I have the weight of big M versus the weight of little m. And what we want to do is we want to talk about how the system accelerates. So you notice this mass moves to the right, and this little mass falls in the absence of friction. So let's go ahead and write down balanced and unbalanced forces for each free body diagram. So for this one, in the y direction, vertical forces balanced, just like in the Kahoot that we did around this. So Fn minus Fg equals 0. And in the horizontal direction, we have acceleration. So we have the tension equals big M times its acceleration. And previously we said that these forces are congruent and these two forces are congruent too. Now for this little m, let's be clear. We have Fg pulling us down. That's the direction of motion, so I'll make that positive. Minus the tension pointing in the opposite direction. These forces do not balance. Unbalanced because little m accelerates. It's not just that it falls, it's that it's falling, gaining speed. So, with this in mind, I am now prepared to plug in numbers. Okay? So I'm writing equations for big M here and equations for little m here. Now let me put in some numbers. I have tension equals 10 times A. And here I have mg minus t equals little m times A. So 5 times 10 minus the tension equals 5 times A. 50 minus tension equals 5 times A. And I have two equations with two unknowns. So I'm going to do a substitution. I'm going to substitute this expression into here, isolate A, and then go back and solve for t. So 50 minus 10A equals 5A. And we're going to end up getting 50 equals 15 times A. When we go ahead and isolate A is going to be 50 over 15, which ends up being 10 over 3, which is 3.3 meters per second squared. Don't do that thing with a repeating bar thing. That's just not, no. And then for the tension, that's going to be big M times A from above. So that's going to be 10 times 3.3, which is 33 newtons worth of force. All right, so that is part 4, where we don't have to worry about friction. And in the next problem, we will incorporate friction in our work.